Far beyond our solar system lies a planet that reflects less light than black acrylic paint. Pitch dark, mysterious, almost invisible in space. Astronomers named it Trias 2b, an alien world so dark it's nearly indistinguishable from the blackness that surrounds it. Discovered in 2006, TRES 2b stunned scientists with its light-swallowing properties, darker than any planet ever observed. Our story begins with a telescope in the Canary Islands, aiming deep into the night sky, searching for faint planetary shadows. Using subtle dips in starlight, scientists identify planets by their transits, tiny eclipses betraying their hidden presence. But one hot Jupiter stood out. TRES 2b didn't reflect light like the others. It absorbed almost everything that struck it. Most gas giants reflect light, glorious bands, clouds, and storms. But TRES 2b? It was darker than fresh asphalt. NASA's Kepler Space Telescope confirmed the planet's darkness, revealing it reflects less than 1% of starlight. That's darker than charcoal, darker than coal, darker even than vantablack, one of the darkest artificial materials on Earth. But why? What could cloak a planet in such total, inky blackness, even as it orbits a blazing star? The planet orbits a star similar to our Sun, located about 750 light-years from Earth in the Draco constellation. Despite its proximity to its star, TRES 2b remains a cosmic shadow, resisting every attempt at explanation. It's what astronomers call a hot Jupiter, a gas giant orbiting extremely close to its host star, heated to thousands of degrees. TRES 2b's surface temperature can reach over 1,800 degrees Fahrenheit, hot enough to melt lead. Yet despite the heat, the planet shows almost no reflection, no clouds, no bright storms, no glint of escaping starlight. One leading theory? The planet's atmosphere may contain vaporized sodium and potassium, which absorb light instead of reflecting it. Metallic vapors and chemical haze could trap light energy, converting it into heat rather than visible reflection. Another hypothesis suggests a lack of reflective clouds. No ammonia, no water, just bare, light-swallowing gas. Unlike Jupiter's ammonia clouds or Venus's sulfuric mist, TRES 2b might be cloaked in sheer, smoky obscurity. Some suggest silicate particles or titanium oxide might be absorbing visible light before it ever reaches our telescopes. What's strange is that such darkness doesn't make it cold. TRES 2b still radiates an eerie thermal glow in the infrared. This ghostly glow can be measured indirectly, proving the planet exists, even if it's practically invisible to the human eye. So dark, yet so hot. TRES 2b redefines our understanding of what alien worlds can be and how bizarrely they can behave. And its orbit? Just 3 million miles from its star, 10 times closer than Mercury travels around the Sun. So close, it completes a full orbit in just 2.5 days, a cosmic sprint through intense stellar radiation. This tight orbit locks the planet's rotation. One side always faces the star, the other plunged in endless darkness. On the day side, temperatures exceed 1,800 degrees, molten atmospheres, relentless heat. On the night side, no one knows what's hiding. Could exotic winds move superheated gases from one side to the other, shifting light and temperature in strange tides? Or might the night side hold cooler compounds, chemistries no sunlight has ever touched? With no surface to speak of, just gas and pressure, TRES 2b may be more a furnace than a world. Yet for all its absurdity, TRES 2b is real, measurable, orbiting, heating, hiding, and still resisting full explanation. The first time scientists graphed its reflectivity, the line hovered just above zero, a planet that barely exists in visible light. How did this world form? Is its darkness a phase, or the final state of heat-scorched worlds? Could its star be affecting chemical balances in its atmosphere, preventing clouds from forming? Or might magnetic or gravitational forces strip away atmospheric molecules, leaving behind only heavy, dark absorbers?